Welcome back to another episode of Learning is Fun with Dustin A. Fife. Today we have a very special guest. I'm just like shocked that we got him here. I am just flabbergasted that we got the one, the only, world famous, platinum record holder, pop star extraordinaire, T. Crit. Hey, today we're talking about ethics. Wow! Oh man, I can't believe this. This is amazing. Okay, so without further ado, let's talk about ethics. So, by the end of today, by the end of this video, hopefully we understand the 3 benefits of unethical research. Can I get a unethical research? Unethical research. Dang, dude. All right, how a risk-benefit analysis contributes to the IRB's decision to endorse a study, how quality of research fits into ethics, the potential risks of benefits, or risks of benefits? Risks of benefits. There is massive risks to having benefits, so be careful. Definition of minimal risk. The role of deception in research. Is it okay? And do all agree it's okay? And then we will talk about p-hacking and researcher degrees of freedom. What is p-hacking? How can you avoid it? The prevalence of unethical practices in psychology. And the last one, the 5 best practices in ethics. I'm actually going to reserve that for in class for reasons which I'll tell you in class. So, without further ado, let's get. So first, why does ethics matter? There are 3 effects of unethical research. Got it. And they are, number 1, undermines the scientific process. Man, that is good. Number 2, impedes advancement of science and knowledge. Woo! And finally, it erodes public's respect. Yo! Good. So we don't want to be the target of embarrassing YouTube videos, do we? And that'll make a little more sense in class because we's going to watch a YouTube video in class. Not this one though. All right, responsibility of the researcher. So the responsibility of the researcher is to perform research that does less harm than good. And in addition to that, we must do quality research. You ever think about that? Quality research is an ethical responsibility. Why is that? Well, if not, the risks do not outweigh the benefit. And then third, the responsibility of the researcher is to be honest in their reporting of experimental findings, which means there is no deception in reporting. So we can't just make up data points. There is no that's what number 2 is, or the second bullet point is. There is no fabricating the data. That ain't right. And there is no p-hacking. So now, well, let's talk about risks and benefits. So oftentimes an IRB makes the decision on whether a study is worth it using a risk-benefit ratio. And one guideline to remember is what minimal risk is. So minimal risk means the procedures and activities in the study are similar to those you would experience in everyday life. So does that mean that it is required to have minimal risk? No. Some situations call for more risk than what you would experience in everyday life. But usually if you have minimal risk, it's pretty easy to get past the IRB, and that's something that we want to aim for, certainly, but certain types of research, by their nature, require a little more than that. So types of risks that can happen are, 1, take it away, physical injury and social injury and mental and emotional stress. Dang, dude. All right, so the IRB's role is to ensure that physical risk is not disproportionate to the benefits. However, a researcher has the exact same responsibility. So a question a researcher can ask themselves, is there some way that I can reduce the risk to participants while having the same benefits? Or conversely, or at the same time, can I increase the benefits to participants so that they more fully outweigh the risks? Now, what about deception? So, deception. I'm trying to remember what this study's about. All right, I could be wrong in this one, but I think what happened in the Kasson and Keichel study, what happened was they had participants come in and asked them to type out a computer or something. They said, do not hit the Alt key, otherwise the computer will crash. And what they ended up manipulating was they would have the computer crash regardless of whether they touched the Alt key. And then they would come in and they would say, dude, you touched the Alt key, even though I told you not to touch the Alt key. And what do we think about people who touch the Alt key? That ain't right, yo. That ain't right. Exactly. You touched the Alt key. Okay, you're in big trouble, mister. And so what they would do is they would have participants sign a form that says where they confess that they touched the Alt key. And I don't remember the exact numbers, but it was like 60% of people touched the Alt key. Or signed a form that signed a confession that said they touched the Alt key. Okay? And so they demonstrated in the lab that people actually do falsely confess to things. So these people didn't touch the Alt key, and yet they confessed to it. So in this situation, deception was used. So what was the risk? The risk was that, people might feel humiliated that they did something that the researcher said they shouldn't do if they start to believe it, or they might feel upset that they're getting blamed for something they didn't do, or they might believe that they touched the Alt. Anyway, lots of potential risks there, but what are the potential benefits? Well, the potential benefits are huge, okay? Prior to probably 1990, people believed that nobody would falsely confess to a crime. Like, why would you do that? Why would you say that you committed a crime and then go to jail? It just doesn't make sense. But the thing is that it does happen. If you go to the Innocence Project's website, it's something like 15, I'm totally making up the number, but my memory of it is like 15% of all people who are innocently or falsely incarcerated for crimes they didn't commit, like 15% or something like that, falsely confess to a crime. Maybe I'll leave a link in the description for the actual number and correct myself. Or maybe I'll do a little cool pop-up number thing. It's actually this, moron. Anyway, so what are the potential benefits? Well, the potential benefits, again, are huge. So we now know that that can happen because it happened in the lab. And if it can happen in the lab, then it can happen in real life. In fact, there are instances of that. So, for example, there is the Paul Ingram story. So Paul Ingram, police officer in Washington State, and his daughter at the time, I believe it was the 1990s, 1980s, somewhere around there, his daughter saw a therapist, and back at the time it was very, very popular among therapists to try to uncover repressed memories. And so the therapist put Paul Ingram's daughter under some sort of a state of hypnosis to try to remember these repressed memories. And then she starts having these memories of her father sexually abusing her. And so she started accusing him of sexually abusing her. And Paul Ingram said, well, I know my daughter and she wouldn't lie. So if she said I did these things, well, I guess I did them. And so he confessed, despite not having a memory. But what ended up happening, this is fascinating, over time he started to develop memories of things that he had actually confessed to. And one psychologist actually came in, trying to remember the exact details, Oh man, I wish I had. Anyway, so they had a psychologist come in and interview Paul Ingram, and she said, hey, you remember that one time you did this? And I can't remember what this is. But she said something very specific that the daughter had said he never actually, or never said that he did. In fact, she denied it in advance. So the psychologist goes in implanting this, or with the intention to try to implant this false memory. And so she asked Paul Ingram, you remember when you did this? And he kind of thought for a minute. He's like, I don't think so, but maybe that sounds familiar. Let me think about it. So the next day, the psychologist comes back and Paul Ingram says, you know, I thought more about it. And yeah, I actually do remember that. Yeah, I did do that. And so she used this in his case saying, look, this was something that the daughter agreed he never did, and yet he has a memory of doing that. So it turns out that memories are malleable. Can we let this guy off? And I think eventually they let him off or released him from prison, but he's still a registered sex offender. Like, really? Come on, people. And so this study, this Kassin and Keichel study, is a great example of a situation where you can implant false memories into people. And that sort of research may not have been possible if we did not allow any sort of deception. So what are the consequences of knowing someone would falsely confess? Well, maybe we ought to put a lot less credibility, because here's another thing that happens. Read a book about this when I was in graduate school, and it's very troubling and very frustrating that this happens. So oftentimes, I don't know about oftentimes, but occasionally what police officers will do is they will bring in a suspect that they just already believe that suspect is guilty. And then in some situations, what they will do, like let's say it's a 17-year-old kid. They will put a 17-year-old kid in an interrogation room and start yelling at him, screaming at him, telling him he needs to confess. And he'll deny it because he's like, I didn't do the crime. And he didn't actually do the crime, and so he's denying it. And then, but then the problem is that they keep him there for hours and hours and hours, and they don't give, and it's in the middle of the night, and so he's exhausted, and they don't give him food, they don't give him water, so he's starving, he's thirsty, he's tired, and they're screaming at him, and they keep saying, listen, all you have to do is confess, and you can go home. You can go home. You can go to sleep. We'll get you a cheeseburger, man. You can go. That's all you have to do. That's all you have to do is sign this form, written confession, and then you can go. What would you do in that situation? Well, knowing what I know, I still wouldn't confess. But if you didn't know what they were going to do, you might confess. And that's what happened. Or that's what happens, is that these people confess. Fine, if you're going to let me go home, I'll say that I did it. Whatever, we'll deal with it in the courts later. So they sign these written confessions, and then they get locked up into prison for the rest of their life. That is annoying. That is frustrating. That is a travesty. And yet it happens. And so this sort of research is important, because it shows that people, yes, they can falsely confess. So quality research. So all research involves risk. Ideally, all research has benefits, and ideally the risks should far outweigh the benefits. If research is shoddy, we will never reap the benefits. That's the basic idea. It is our moral obligation as researchers, if we are using human participants, to do high quality research. Otherwise, the risks will not, or the benefits will not outweigh the risks. And then finally, getting into my pet area as a statistician and as one of my research areas is honestly reporting results. So p-hacking. So hopefully you read the article about p-hacking, the Simmons, Nelson, and Simonson article, although there's been lots of discussion about this. So what is p-hacking? So p-hacking is basically the idea that you go into a data set, you have a pre-existing hypothesis that you want to prove, or you want p to be less than 0.05, and you run the experiment as you think it should, or you run the data analysis as you think it should be run, and let's say p is equal to 0.15. Well, you can't publish with p is equal to 1.5, and so what do? Well, you're like, oh, you know what, I measured like 5 dependent variables, so I'm going to try different dependent variables. I'll try this one. Nope. Try this one. Nope, that didn't work. Try this one. Nope, that didn't work. Well, you know what? There was something kind of funny about the last 4 or 5 participants. I can't quite put my finger on it, but I'm going to run the data without those last 4 or 5. Oh, there we go. Hypothesis proven. That's p-hacking when you start trying different things. You try using different dependent variables. You try analyzing with or without certain covariates, or you try analyzing only subsets of the data. Basically, you're doing lots and lots of different things to try to get statistical significance. Now remember, when you're talking about a p-value, it's like rolling a dice. Okay? P less than 0.05, that's a rare event. But if you roll the dice enough times, eventually even a rare event becomes common. So why would that fall under ethics? Well, the problem is if you are reporting your results as if you did it in one shot, and yet it took you 15 shots to get statistical significance, that's an ethical violation. On the other hand, it's important to think about a distinction between intention. Now, this may be a little more philosophical than we're ready for in this class, but if somebody does p-hacking unintentionally and doesn't realize that there's a problem, is that an ethical violation or is it not? I don't know. That's a good question. If somebody was speeding, and they didn't realize they were speeding, do they still get a ticket? Yeah. So is it an ethical violation? Some might argue, yes, it's still an ethical violation. I don't know. I tend to think that people who p-hack and are caught p-hacking and didn't have malicious intentions tend to be like Brian Wansink we talked about. Looked like the guy just genuinely had no idea what he was doing was an ethical problem. And it's unfortunately he got fired from his job, but it is what it is. So p-hacking, and that's something that Andrew Gelman says a lot, is it's important. I mean, p-hacking kind of has negative connotations. It seems to imply that people are intentionally and knowingly trying to toy with the games of probability. But my suspicion is that most researchers, if they're p-hacking, they don't realize they're p-hacking. They don't realize what they're doing is an ethical violation. So how do we avoid p-hacking? Well, one of the best ways we can do it is through pre-registration. So we have a hypothesis, we have a particular dependent variable we think should be the measure of it, we have a particular sample size that we want to collect. We pre-register those things long before we even collect data. We post it online and say, hey, this is my analysis plan, and then you stick to it. And that's the way psychology is moving. That's, I would guess in 10 years that's going to be the norm rather than the exception. I'm not necessarily sure that's a good thing. Some have bristled against that idea that everything needs to be pre-registered because where does discovery come in? And what about issues of external validity and internal validity? And why are we focusing so much on replication? And those are valid points. But I do think that pre-registration needs to play a bigger role. And I also think that the role of exploration and discovery needs to be more clearly delineated. So see Fife, possibly some other authors, 2019-ish, writing a paper on that. So anyway, if you're interested, we can talk about it more. All right, and here is a helpful graphic I just made up yesterday that helps to delineate between p-hacking and ethical data analysis approaches versus unethical approaches. And I tend to see the different approaches falling on 3 different dimensions. So we have on our y-axis the confirmation versus discovery, and it's a continuum. You can fall anywhere on that continuum from 100% confirmatory to 100% exploratory. And then another continuum is theory-driven versus data-driven. And so what that means is, are your analytic decisions being driven by theory, or are they being driven by data? And the third dimension that is displayed is the color. So black means that the intentions of the researcher are made transparent. And dark red means that the researcher is intentionally misleading people into believing something that is not true. Whereas the somewhat transparent red says that they're not intentionally misleading people, they're just omitting important information that is important. Important information that is important. Can I get a note? Important, that is important. Yeah, yeah. Thank you. So, if you notice that rough EDA, which basically, I think that's what most researchers do, they're kind of halfway between confirmation and discovery. They haven't quite figured out exactly all their exact analytic approach, and so they might do a little bit of exploration, but for the most part, they're testing a specific hypothesis. And in addition, they are driven by theory. They have a hypothesis because the literature says something, but they're also open to having the data influence their decisions. So that would be what we call rough CDA. And as long as you're transparent about it and saying, hey, look, I made these various decisions on my way because the data suggested different things than I initially anticipated. That's fine, as long as you're transparent about it. What is not okay is when you're p-hacking, when you're not transparent about how the data is influencing your decision or about how there are elements of discovery in there. And in the bottom left quadrant, we have phishing, which basically means that you're not being guided by theory at all, and you're just trying to find something interesting in there, and so you do test after test after test after test, and report that which is significant, but not telling people the ones that failed and how you got to your final decision. And then harking, H-A-R-K, stands for hypothesizing after results are known. Very close to phishing, so the difference between phishing and harking. In phishing, you report only what is significant, whereas in harking, what you do is you find something that is significant and then write your introduction section as if that is what you predicted would happen all along. Now notice these are all very close to data mining, which data mining is a data-driven strategy. Basically, you're relying 100% on data, very little or if at all on theory, and you're doing it with the intent of discovery. Ain't nothing wrong with data mining as long as you tell people that's what you're doing. And so those are the distinctions, and those are important distinctions. By the way, in the top right, which is strictly confirmatory, it is 100% theory-driven and 100% confirmation. And in that situation, you are not allowed to make any sort of modifications to your plan. And if you do make modifications, your p-values become meaningless at that point. So you get one shot, and that's where strictly confirmatory is. And that's what pre-registration aims to do, is it tries to tie people to a strictly CDA approach. And notice the circles in the graph. So the circles indicate that there's a lot of leeway. So rough CDA can be more confirmatory than discovery in some situations, and vice versa. It can also, on some occasions, be more theory-driven than data-driven. Other times it might be more data-driven than theory-driven. And so that's what the circles represent, whereas CDA, notice it has a very narrow circle because there's basically no leeway when it comes to CDA. So hopefully that's helpful in understanding the distinctions. So with that, let's go ahead and review the objectives. Objectives. Man, I want you on every show, dude. Every show. Man, I can't believe I got this guy. So, this week's objectives, hopefully we understand the 3 effects of unethical research. We understand how a risk-benefit analysis contributes to the IRB's decision to endorse a study. We understand how quality research fits into ethics. We also know the potential risks, such as physical injury, social injury, and mental and emotional stress. We know what minimal risk is, and we understand the role of deception. And by the way, I forgot to mention this. Some people disagree. Some people say that deception is never okay. And read your book because that's an important argument to make. So go ahead and read your book for more information on that. And then we talked about p-hacking and researcher degrees of freedom, and then the prevalence of unethical practices in psychology. So ladies and gentlemen, thank you very much for joining us today, and make sure to give a special round of applause for T-Crit. Thank y'all. Appreciate the opportunity to be here. It's been a pleasure. No, it has been our absolute pleasure.